Okay, and I'm back. We are going to look at how to convert points from the polar system into the rectangular system and vice versa in this video. The equations that you need for doing this are written here. So if you're writing this on your own paper, you might want to pause the video and copy these down first. If you have the guided notes printed, you can just follow along because they're on there. Same thing with these problems. These are the same from the guided notes, or you can write them yourself. We have 2 pi over 4. Wanting to convert that into rectangular coordinates. These are the equations that you're going to use, these top 2 equations here, to go from polar to rectangular, okay? So to go from P to R. And it's really simple. So this is R and this is theta. You just plug them directly in, okay? You just plug them right into the equations. So you're going to have x is equal to r cos theta. So in this case, x is going to equal 2 times cosine of pi over 4, which is 2 times, if you look on your unit circle, uh-oh, this got hit by a baby that's running around. Okay. All right, if you look on your unit circle, cosine of pi over 4 is actually square root 2 over 2. And if you simplify that, you just get square root 2. So that's our x coordinate. The y coordinate, we use y equals r sine theta. So it will be 2 sine of pi over 4. Okay, and then we simplify that again. This is a coincidence, but pi over 4 has the same sine value as it does cosine, right? They're both square root 2 over 2. So that usually doesn't happen, but for this angle it does. The 2's can cancel out again, so you get square root 2 again. So we got the same answer for x and y. Square root 2, square root 2 is our answer. All right, now let's do the same thing for this one. So the x value, it's going to be r cos theta, so 4 cosine of pi. So 4 multiplied by -1, so -4. And the y value is going to be r sine theta, so 4 sine of pi. Sine of pi is 0, so 4 multiplied by 0 is 0. So our point is -4, 0. It would be a good idea for you to think about how you plot this in polar and how you plot this in rectangular and make sure that they actually do seem like they would line up. All right, let's take 1 second to do that and draw a really little graph here. So this is the r value, this is theta. So remember we locate theta. If theta is pi, pi is over here, and we go out 4. 1, 2, 3, 4. Mark our point. Now in the rectangular coordinate system, this is x and this is y, so we go out 1, 2, 3, 4 in the negative direction on the x-axis, don't go up or down on y, right? So those do match up with each other. And you could do the same thing with these. All right, let's jump over here. This is a little bit harder to go from rectangular to polar. We're going to use these equations. So to go from r to p, use those. So this is x and this is y. Our first equation says that x squared plus y squared is equal to r squared. And so if we plug the values in, -4 squared plus 4 squared is equal to r squared. And simplifying that, we have 16 plus 16 is equal to r squared. That is 32 equals r squared. And then we're going to take the square root of both sides, all right? So r would be, we can simplify this. 32 is 16 times 2. Square root of 16 is 4, so it's 4 radical 2 is our r value. We need to figure out theta now. We use this formula to do that. So tan theta equals y over x. So in our case, tan theta is going to equal, I'm going to steal a little space up here. Tan theta is going to equal y over x, that's 4 over negative 4. So that is negative 1. Where is tangent of theta equal to negative 1? So if you have your unit circle, you can look. There's two options. It's either 3 pi over 4, or it is going to be 7 pi over 4. Which one is the correct answer? Because there's only one correct answer. How do we know? Well, it's totally dependent on what quadrant this point's in. What quadrant would this point be in if you were to plot it? Negative 4, 4. You would go this way, then up, right? That'd be the second quadrant. So this is in quadrant 2. So which one of these angles is in quadrant 2? It's this one, right? So we get rid of this one. So that's theta. So our point is always r theta. So we got r was 4 square root 2. Theta is 3 pi over 4. Okay, so we have 4 square root 2. 3 pi over 4 is our final answer for A. Okay, now let's do B. So I'm going to erase this stuff. I'm just going to get rid of A altogether. So we're going to focus on the point 4, 5. So again, this is x and this is y, and we need to figure out what r and theta are. So we use these formulas. X squared plus y squared equals r squared. So that means 4 squared plus 5 squared has to equal r squared. That's 25 plus 16 is 41. 25, 35. Yep, 41. Take the square root. So r is the square root of 41. Okay, now we need to find theta. Tan theta is going to always equal y divided by x. So 5 divided by 4. That doesn't happen on the unit circle, right? It's not one of those exact values that we see on the unit circle for tangent. So that means we need arctan, the inverse tangent. So theta is going to be the arctan of 5/4. Well, and that is because this is in Q1, right? Because normally this would give us a reference angle, but that is equivalent to the Q1 value. So we're good there. We could write our final answer in an exact form like this. Just keep it all like this. But I think a lot of times they'll have you round. So you'll have to look and see what they want you to do on your homework. Pay attention to the directions. If we rounded these values, the square root of 41 is about 6.4. And if you find arctan of 5/4, right, arctan of 5/4, you get about 0.9. So that's approximately what the point is in polar form, right? This is r, this is theta. And that's how you do that.